So welcome to trigonometry. Section 2.1 is going to start introducing you to a lot of things about what we're going to need in this course, particularly angles. And let's start out with the most basic thing. We're going to use something called the unit circle. I'll talk about that later, but the unit circle is going to be a big important part of what we do. You don't have to draw this on your in your notes. But let me just kind of fill this in here for you a little bit. The equation for this is x squared plus y squared equals 1. And just a reminder from your algebra classes, the center of this is at 0 and 0. What's the radius? Does anyone remember that one? What's the radius of this going to be? 1. So center at 0, 0, and a radius of 1. Now, when we deal with circles, a lot of times what we're conditioned to is thinking of things in angles. So that's fine. And let's do a little bit of history here. How many angles are there in one full circle? 360. Yeah, 360. So 360 degrees, that's turning completely around. So if you had a 720 degree angle, that's twice around. I remember Shaun White, who was a snowboarder in the Olympics, he did a 1080. That's 3 times around. That's 3 turns completely around. That's pretty impressive. But why do you think there's 360 degrees in one circle? Why did people choose 360 as, okay, that's once around? I've heard 2 different versions of that story. I don't know if you guys have heard anything or not. So, one of them might be urban legend, but the one I like the best is that 360 degrees is close to the number of days in a year. And your early astronomers would kind of look and see, oh yeah, we're coming back to about the same point. So, that's one possibility. The other one that I think might be more plausible, but not so much very romantic, is that when you have these special triangles called equilateral triangles, equilateral triangle means each of these sides have the same length, that the angles here are 60 degrees. And you can fit 6 of these into a triangle. And it goes back to the Babylonians and the way they dealt with their number system, that it kind of relates to base 60 as opposed to base 10. Regardless of that, an angle like this, starting here and going up here straight, that should be a familiar angle. How many degrees in that one? 90 degrees. 1/4 of 360, that's your 90 degree angle. And of course you got 180 and stuff like that as well. So let's draw a couple other angles. Now typically speaking, when you're dealing with angles in standard position, angles in standard position, you're going to put the initial side on the x-axis, the positive x-axis, and then the terminal side is going to be some distance later. So problem number 12, I think it is, asks us to draw a 60 degree angle. Let me just double check that there. Yeah, problem number 12, 60 degree angle. So here's going to be your initial side. Now I know a 90 degree angle would be straight up like that, but I don't want a 90 degree angle, I want a 60 degree angle. So that's going to be about 2/3 of the way. And I'm not going to take out a protractor to try and measure that. I'm just going to kind of guesstimate a little bit. So there you go. And you've got your initial side and your terminal side. And that's your 60 degree angle. So that's problem number 12. Problem number 14 asks you to draw a negative 120 degree angle. How do you suppose I'm going to draw that? what's going to happen when we go negative 120 degrees as opposed to, say, positive 120 degrees? Yeah, you're just going to go the other way. Instead of going counterclockwise, which you do for your positive angles, you're going to go clockwise. So again, we'll start out on the x-axis, positive x-axis. So your initial side is here. And since 120 is bigger than 90, you're going to have to go past this axis down here and into the third quadrant. So about a third of the way there. And again, you've got your initial side and your terminal side. And that's going to give us a negative 120 degree angle. Nice. Nice, nice. Now, angles of 1 degree can actually be pretty big, especially when you start traveling a long, long distance. So a lot of times we'll break down our angles from degrees into smaller units. Now you can go with decimals, and sometimes we'll just work with decimals, but sometimes you just want to work with different notation as well. So let me introduce a couple other things here. 1 degree can be broken down into 60 minutes. Now the unfortunate thing here is that some of this notation is used elsewhere in different ways. But let's keep on breaking things down. What do you think I can break 1 minute up into? What would make sense? 60 seconds. Thank you. 60 seconds. Like that. So, for instance, the city of Royal Oak has a latitude and longitude like this, 83 degrees, 8 minutes, and 47 seconds west. And then our latitude would be 42 degrees, 28 minutes, and 53 seconds. And that, of course, would be north. Let's try and break down or understand what that would be and maybe change it into some different units. So, we'll do that with problem number 26. So problem number 26 in the book gives you 73 degrees, 40 minutes, and 40 seconds. Oops, 40 seconds. There you go. What we'd like to do is we'd like to write that just using a decimal. I don't want this minutes and seconds stuff. Just write it in the decimal form. So we'll attack it in 2 parts. We'll first start with the smallest unit. Let's convert 40 seconds over to minutes. So I got 40 seconds. And I know that 1 minute has 40 seconds in it. So let's keep in mind 1 minute has, I said 40, I meant 60. 1 minute has 60 seconds. So what I'm going to do is I'm going to multiply by something to convert from seconds to minutes. Here's the trick. We're going to multiply by 1. Does multiplying by 1 change anything? No. If your boss said, hey, we're going to take your salary and multiply it by 1, you're not going to say, hey, whew, boss, really, you treat me too kind. No, he's not going to be suddenly on your Christmas card list because that's not going to change anything. But if you're clever with the form of 1, then you can make some nice changes. The units that I want to cancel are the units of seconds. So let me write that on the denominator. 60 seconds is equal to 1 minute. And if you look at that, that's a fancy way of expressing the number 1. Those two things are the same. But there's something cool about multiplying it like this, right? And that is, these units cancel each other out. It is degrees and degrees cancel each other out. All right, so that leaves me 40 over 60. And the units that I'm left with are minutes. And of course, that's 2/3. So 2/3 of a minute. Okay, that's great. So what I've done now is I've said, all right, well, now that we can rewrite this as 2/3 of a minute, let's rewrite the whole thing as 73 degrees, 40 and 2/3 of a minute. To finish our work, I want to convert from 40 and 2/3 of a minute up to degrees. I'm going to get a decimal value, but that's okay. That was what my goal was. So now I got to get rid of this little piece right here. I got to convert degrees or minutes to degrees. So and let me remind ourselves, 1 degree was 60 minutes. So when I take this little portion here, 40 and 2/3 minutes, I'm going to multiply it by something to get rid of the units of minutes and end up with degrees. So what should I multiply by? Perfect. 1 degree over 60 minutes. Let me say it again. The units that you want to cancel should be in the denominator. So, yay. And check it out. Minutes cancels out, and you're going to be left with degrees. You're going to be left with 40 and 2/3 over 60. Let's see if we can't get that out of our calculator. So, let's see. Let's see. 40 plus 2 divided by 3. Hey, that's 40 and 2/3, right? And then hit the divide key. Divide by 60. And, all right, you get something there, 0.6777. All right, so 0.6777. And then you can round it off from there, because our goal was to turn that into a decimal. So altogether, this could be written as 73.677. I'll round it up to 8 there. 73.6778 degrees. So you got rid of all those units and you converted it to just degrees. Yeah.
So you added 40 and 2/3.
Yeah, I added 40 and 2/3. Now, there's a fancier way to do that, but this is something that should work in pretty much most of your calculators. I added 40 plus to the 2/3, and then I divided by 60. If you've got one of these fancy TIs that I was passing out, there's kind of a cool way you can do this. If you hit the alpha key right here, third button, well, second button down on the left underneath the second button, alpha and then y equals, it gives you a few options to write fractions. And the one we want to choose is the second one down, because we had a mixed number. We had 40 and 2/3. So if you choose this one, you can type in your number 40, and then you use the arrow keys to do 2 divided by 3. And there's your 40 and 2/3. Now we're going to divide by 60. Oh, it gives me a fraction. All right, 61 over 90. Well, that's pretty cool too. So if you want to figure out what the decimal value is, you can just divide like that. But it's a nice little trick. It's not something that I'm going to require, but it's pretty nice. All right. How are we looking with that first one? You okay with those units? This kind of stuff is handy because when you start talking about longer distances, then these small angles make a big, big difference. If you were to look at the Earth from the sun and measured out an angle of 1 second, so 1 second is a really, really slender angle. That's 1/3,600th of a degree. If you look from the sun at that angle, 1 second of arc would be about 450 miles on the Earth. So that's a big drive. It'd be like driving from here in Royal Oak down to about Elizabethtown, Kentucky. So past Louisville. If you say Louisville, they're going to know you're a Yankee. It's Louisville, 2 syllables. Anyways, 450 miles, that's a pretty big difference. So a lot of times in astronomy, you'll see things that go down into small fractions of a second in terms of their angles, just because they're dealing with some really, really big distances. Okay, how are we looking with this one? Okay. Has anyone ever noticed anything if you drive up to Gaylord? Along your way to Gaylord, you pass something kind of fun. So up on I-75, you pass the 45th parallel in Michigan. And along it, you'll see something interesting. Now, the 45th parallel is interesting because you're halfway between what and what? Halfway between the equator and the North Pole. So, kind of interesting that it's right there up in Gaylord. So look for it next time you're on I-75 heading north. All right. Do you want to do another one like this, or are you okay with this? You good with that? Or you want to do another one? Which one is it? Another one? Another one. All right. Let's do another one. And this one will work out a little bit friendlier. It's problem number 24. So 61 degrees, 42 minutes, and 21 seconds. So try converting that from degrees, minutes, and seconds to just degrees. Now, I'm not sure what happened with the software. They wanted $850 to configure the software. So the software that I use to record these lectures doesn't allow me to pause. I can either stop or start. So I have a manual pause. So if you're watching this at home and you see pause, just fast forward through. That's my workaround. All right. I'll give you a minute to work on that, and I'll walk around and help out. write that as, let's see, it should be 0.35, right? So 42.35 times that, and then I'm dividing that by 60. So yeah, there's nothing wrong with that. You don't have to write it as a fraction, is what I'm saying. I'm looking for decimals there, so I mean, it's foolish, you remember that. I'm sure I know who taught you that trick. But yeah, okay, no problem. I was saying about yeah. So I want the answer in decimals. All right.
Yeah.
Um, yeah, it doesn't look right.
Okay.
You'd actually need parentheses around. You would multiply the fractions together and then added that. You need to put parentheses around the 42 plus the fraction and then multiply it. That's just these two. 42.35. Now you got to convert. So that's in units of minutes now. And now you got to convert that to degrees. So you got to take that for the finish converting. All right, cool. So you got that number. That gets added to 42. So it'd be 42.
Thank you.
Of course. You know,
I was going to ask for a
I work the other way.
it was much more
It works.
complicated like that. Like there's a reason for showing us that this way.
Yeah.
No, that's fine. That's why I wanted to know.
I think if you did it the other way, I don't know.
Maybe later.
It makes me nervous. It makes me nervous.
I got
Look,
it.
it's not a big thing.
That's why I asked. I wanted to.
I mean, this kind of problem is maybe one problem on a test, or not even on the final. It's not a big thing, but it's something that you should be aware of. That's all. Somebody had my hand. Oh, right here.
I had to come over here. But.
Yeah, which is 0.35.
Yeah.
Okay. So what you can do is you now know that that's 42.35. All right, and then you got to divide that by 60 to finish it up.
Thank you.
Right? Okay. We'll just do. Oh, this should be 42 there, not 40. Not 40, right? That was a problem. 42. Yeah. All right. All right. Okay. So let's take a look at this one then. Work from smaller to larger units. So we'll take the 21 minutes. And again, when you're multiplying by 1, we're going to see this later. And you're going to do this a lot in this course. So if you can get used to it now, that's great. When you multiply by 1, the units you want to cancel are going to go where? In the numerator or denominator? Denominator. It sounded almost like a unanimous decision. All right, so the denominator. So it's 60 seconds in 1 minute. And the units that you want to cancel go in the denominator, so we can get rid of units of seconds. And I end up with 60 or 21 over 60. And those units are going to be minutes. If you did a decimal value, which in this case is nice and convenient, it's 0.35. So great. That means that we can rewrite this as 61 degrees, 42.35 minutes. To finish this up, you want to convert minutes to degrees. So we'll play the same game again. 42.35 minutes times what? What over what? Good. 1 degree, 60 minutes. And again, you're going to get some nice cancellation. Units of minutes cancels out, and you're left with 42.35 over 60, and that's going to be in degrees. Probably finish it out by getting a nice decimal value here, which is what I was looking for. So 42.35 divided by 60, 0.7058, we'll call it. So 0.7058333. And when we round that off, that's when I use kind of like a little squiggly approximation sign, 0.7058 degrees. Add that to the start here, we end up with 61.7058 degrees. Doing okay on that one now? Feeling comfortable? All right, that's good. That's good. Thank you. Let's try one in the other direction. And that's going to be problem number 32. So 29.411 degrees. Want to convert that from degrees to degrees, minutes, and seconds. So we'll kind of do the reverse process. We'll start out with 0.411 degrees. We'll start by converting that first to the next bigger unit. So what unit am I going to convert to next? What's closest or closer to degrees? Minutes. What should I multiply by this time? Good. 60 over 1, right? You've got 60 minutes in 1 degree. And this is a good thing. If you can see that these units cancel, I mean, that's really helpful, because that lets you know you should be dividing instead of multiplying, or vice versa. The units of degrees cancels. And that's what we wanted to see. So 60 times 0.411 is 24.66. All right, cool. 24.66, and that's in minutes. Nice. So I'll rewrite this as 29 degrees, 24.66 minutes. Now I'm almost there, but I got a little piece here that's still hanging on. Remember, I wanted this in degrees, minutes, and seconds. So let's see if we can't take care of that little decimal value here, the 0.66. So take the 0.66 minutes, and again, you're going to multiply it by something. This time I want to get rid of units of minutes and end up with seconds. So see if you can't figure out, well, what's going to go where? What fraction am I going to use here? Taylor? Perfect. 60 seconds over 1 minute. And then, quite predictably, units of minutes are going to cancel each other out. So 60 times 0.66, I'm thinking 39.6. Is that right? Thank you. 39.6, and that's in seconds. So to finish this up, I've got 29 degrees, 24 minutes, and 39.6 seconds. Yeah. All right. How are we looking with that one? Looking okay there? So that's a little bit of a new unit for you. If you haven't taken trig before in any form, then degrees, minutes, and seconds is something that's new to you. We're going to move on to something that's even more new. And let's see. We're going to talk about a different way to refer to angles. It's called radians. The reason we use radians is because that's what's used in calculus. Everything is done in radians in calculus. And the unfortunate thing is that we didn't grow up with radians. So let me give you a little demo on radians, what radians are. We're going to start out with a circle, a radius, whatever, call it R. Thank you, R. Now that R is going to be the distance that we're going to move around the circle to mark off certain angles. Like if you see here, we laid it down, we've moved a distance of 1 radian. Now 1 radian turns out to be about 57 degrees. And then 2 radians. How many radians do you think you need to get exactly halfway around the circle? Yeah, about 3.14, right? Pi radians. So pi would be halfway around the circle. How far for all the way around the circle? 2 pi. So let's kind of write both of those things down. No, it's not the one I want. There we go. And the big takeaway that you should get is this. So we're going to talk about radians. 2 pi is equal to what angle in degrees? 360. And if you notice, we got a factor of 2 that's common to both of these. So pi itself would equal what? 180 degrees. And that's the one that you should hang your hat on. That's the one you're going to use a lot. And we're going to use this to convert between the familiar angles that we're used to, which is degrees, and radians. Radians, like I said, it's a different way to think about angles. But converting here is going to take advantage of the same thing that we used just a minute ago, and that is multiplying by 1. So let's start out with problem number, let's see, problem number 36. We've got an angle of 120 degrees. Okay, 120 degrees. Well, in order to convert degrees to radians, I'm going to multiply by 1. Now I know that pi equals 180, and I know I'm going to write a fraction here. But what goes in the numerator and what goes in the denominator? Try and write it down. Don't shut it out. Try and write it down. And now check with a neighbor. Compare your answer to neighbors. Like, is it 180 over pi or pi over 180? Check and see if you guys are on the same page. And feel free to introduce yourself as well. Say, hi, my name is Jeff. Cool. So do we have a consensus? What goes in the numerator? Pi and 180 in the denominator. And that's nice because units of degrees will cancel. And let's see what else. You're going to be left with 120 over 180 times pi. I'm really hoping that you simplify that for me. You don't leave it as 180 or 120 over 180. How does that simplify? What fraction? Go ahead, by the window. Yeah. Well, 2/3. Yeah, thank you. 2/3 pi. All right, 2/3 pi. You could write the pi in the numerator as well. If you wanted to write it that way, you could write 2 pi over 3. That's the same thing. I have really no preference for one versus the other. Let's try another one. Are we okay with that? Do you understand why we're putting the 180 in the denominator? It's because it cancels when it's in the denominator. Now, problem number 38. 330 degrees. And problem number 44. negative 225 degrees. Why don't you convert, I'll see, I'll help you out with the first one, and then I'll ask you to do the next one. What am I going to multiply by on this one to convert to radians? Yeah, same thing as last time. Pi over 180. Now, you'll end up with 330 divided by 180 times pi. If you don't want to think, that's okay. We don't have to do that, right? Let's make our calculators do that. That's why we spent 180 or 100 and some bucks for these things. Now, you could easily cancel out the zeros and then divide by 3, but you know what? Here you go. Type in 330 divided by 180, and you get a decimal value. But then you hit the math key. What's magic down at the math key? Answer to fraction. You press enter twice, and bam, you get a nice fraction. Actually, mine turned it into a mixed number. The mode is probably reset a little bit differently. Most of you will get a fraction like this. If you have your fraction as just a regular fraction, when you do that, you get 11 over 6. So that's kind of what I was looking for. So 11 pi over 6 for your final answer. So 11 pi over 6. Yay. Why don't you try problem number 44? Play the same game. So James, what am I going to multiply by in this case? Yeah. So I want to get rid of units of degrees. So I'm going to multiply by pi over 180. That's going to give me negative 225 over 180 times pi. We'll play the same game that I did last time. As I'm going to put in my calculator. I'm not going to bother with the negative. I know it's going to be negative. Hit the answer fraction key. You should get 5/4. So overall, your final answer should be negative 5 pi over 4.
Negative matter.
Yes. Yeah, I want the negative there. Yeah. Because that means you're going clockwise versus counterclockwise from the starting position. So yeah, thank you. Let's do a couple in a different direction. Let's start out with an angle in radians and come up with an angle in degrees. By the way, any guesses real quick? Let me take a look back here for a second. What do you think a 90-degree angle is going to be in radians? Can anyone just kind of piece that out? Yeah, half pi, pi over 2. Remember, all the way halfway around the circle is an angle of pi. So a quarter of the way around the circle is going to be your pi over 2 angle. And this is going to be 3 pi over 2. And then, of course, 2 pi as well. So, some special angles. You got 180, of course, is pi. That's going to become pretty old hat by the end of the semester. For now, it's a little bit on the new side. Let's try problem number 50. Negative 2 pi over 3. This time I want to convert from radians to degrees. also do number 58, negative 3 pi over 4. Both of these need to get multiplied. See what you can do. Okay, so let's see. What are you going to multiply this time? What do you multiply by? Thank you. 180 degrees over pi. And the nice thing is that the units of pi are going to cancel out. We'll do the same thing down here. 180 over pi. So units of pi are gone. That's nice. So you end up with negative 2 times 180 over 3, and that's going to be in units of degrees. So it's going to be what? Negative 120 in degrees. All right, one down below. This time, let's just kind of skip to the happy ending. What are we going to get in terms of units of degrees? Negative 135. Please don't skip the negative. It is kind of an important part of that angle. It's telling you going clockwise as opposed to counterclockwise. We're looking good on those? All right. Just a couple more to wrap up a little bit of work here on angles. And that's problem number 60. So far, everything's worked out really nice and neat. But it doesn't have to. If you have a 73-degree angle, well, if I want to convert 73 degrees to radians, let me just say it's not going to work out even. So what should I multiply by? You got two choices. Pi over 180 or 180 over pi. What is it? You could, but I would just keep it simple. I would just do the pi over 180 still. Yeah. I mean, what you said is not wrong, but it seems to me to be a little bit more work. So I'm going to just stick with pi over 180. What cancels here? Not just the degrees, right? The rest of it, you're going to have to do on your calculator. Now, where do you find pi on your calculator? Because I really hope you don't type in pi. But in case you forget pi, I've got it there on the right-hand wall. You see it up at the ceiling? It's your first 60 digits of pi. By the end of the semester, I want that all memorized. Okay? All right. The interesting thing about that is that I think after about the 32nd digit, you can calculate the circumference of the universe to within the diameter of a proton. So it's a fancy way of saying you really don't need anything past the 32nd digits, ever. But they calculated pi out to trillions of digits. And in fact, we can celebrate Pi Day coming up pretty soon. Does anyone know when? March 14th, exactly 2 months from today. So Pi Day 3.14. All right, we'll do some more stuff on it then. But as far as your calculus is concerned, pi is right above the up arrow key here. So we want 73 pi divided by 180, and you're going to get this ugly looking decimal, but that's our answer. If I rounded that to the nearest 10,000th place, the 10,000th place is a 0. You look to the right, since it's more than it's 5 or more, we'll round up. So 1.270, or excuse me, 409, etc. And that rounds to 1.2741. When you're rounding, if you have a 0 in this place, if I didn't have a 9 here, if I had like a 1, if I'm expecting something in 10,000th place, make sure that you end in a 0. Don't just leave it off. Problem number 68. One like this almost always appears on your exams. So let's just be careful with this. 3 is our angle. What units is it in, though? What would you guess? Radians. Because if it was in degrees, I'd have to have a little degree symbol. But just because something is in radians doesn't necessarily mean it has to have pi as part of it. Now here's the thing. We want to convert from radians to degrees. So you've got two choices. What are you going to multiply by? What over what? 180 over pi or pi over 180? 180 over pi, because you want to get rid of units of radians and get units of degrees. Even though you don't see a pi there, it's there. 180 degrees, pi. And so this is going to be 540 degrees over pi. And then we can do that on our calculator. 540 divided by pi is about 171.8873 degrees. So that's your angle in degrees for 3 radians. If you're curious, you can just take that, hit the divide key, divide by 3. So 1 radian, like I said earlier, is about 57 degrees, a little bit more than 57 degrees. All right. How are we doing there? Hear that in the distance? That's my ride. See ya.